Hi, everybody. Deborah Danielson here, and today we're going to talk about increasing and decreasing functions and the average rate of change. And this won't be too bad. It'll be kind of easy to do. And we're going to start off by talking about increasing and decreasing functions. And increasing and decreasing functions are super easy if we're just talking about a nice linear function. If it's just going upward, it's an increasing function. If the function is going down like this, it's decreasing, right? Just like up the slope, like a ski slope is increasing, and going downhill, like down the ski slope is decreasing. But what about when you get like a crazy function like this, right? Then what do? Do we call that increasing? Do we call it decreasing? I mean, it's kind of a combination, right? So how do I describe that as increasing or a decreasing function? So to do that, we're going to use the interval notation that we've been working on to be able to describe the portions of the function that are increasing and decreasing, right? You can see we've got a portion that's increasing, and then it starts to go down the hill, decreasing, and then it goes up the hill again, so that portion's increasing. So you're going to use your interval notation to describe the different parts. So this function is increasing on two parts, increasing on the first interval, right, which would go from A to B. And then it's increasing again from C to D. Okay, so increasing from here to here, and then increasing again from here to here. So it's increasing on two different intervals. Okay, and then we can describe that function as decreasing on the interval from B to C, right? This kind of interval in the middle where the value of y, or the function, is going down, then that's the interval it's decreasing on. Okay, so now we've described the whole function. It's a combination of increasing and decreasing intervals. The only thing that could be a little bit confusing, and I'm sure some of you are kind of wondering about it even now, is the fact that on B, right, we've got two brackets. How can it be a bracket on both B's, right? Both increasing and decreasing? Maybe it doesn't make a ton of sense. Like maybe we're thinking maybe one should have a bracket and one should have a parenthesis, right? Like how can it be brackets on both increasing and decreasing? Same thing as C, right? We've got a bracket on both increasing and decreasing for C. The only thing is you can't really tell, if you think about it, you can't really tell by looking at that graph, right? Should increasing be a bracket and decreasing be a parenthesis, or should increasing be a parenthesis and decreasing be a bracket? I don't know. You can't tell, right? We just know it's included, right? The function has a value at B, so we have to make sure that it's included. And you can't tell by looking, right? Should one have a parenthesis and one have a bracket? I can't tell which one it is. So we just put a bracket on both. That's the convention, right? To make sure it's included and it's not inaccurate by making sure it's included on both. Okay, so we just put a bracket on both B and both C's. Okay, all right. So that's how we write increasing and decreasing functions, or if you have like a combination of increasing and decreasing parts of a function, that's how you would write it. All right. Okay, so now we're going to talk about average rate of change. Average rate of change. All right, so if I have a function, I'm just going to go ahead and write it on the little graph here. Okay, let's say my graph looks like that. That's my function. Okay, and let's say it goes, I'm particularly interested in, we'll just say from here to here. This is A and this is B. Those are my two X's, A and B. So over on the Y-axis, this would be the value of my function at A. And this would be the value of my function at B. Okay, the rate of change across this portion, okay, would be the change in y over the change in x. And when we were working with just linear functions, just straight lines, we called that the slope, right? It was the slope. The average rate of change was the slope. And the way we calculated the slope was the change in y over the change in x. Maybe you wrote that as delta y over delta x, but some way you wrote the change in y over the change in x. Okay, now this isn't linear. So, it's going to be different over different parts of this function. Like if I do this little section here, it's going to be much different than if I did a section, say, over here, right? Different sections of this function are going to have very different answers. But I'm just interested in particularly this section from A to B right now, right? Okay, change in y over change in x. The y for this particular little segment of this function is going to be f of b minus f of a. That's the change in my y's for that section. Okay, so the change in y is going to be f of b minus f of a. The value of my function at b minus the value of my function at a, the change in the y's. And then the change in my x's for that particular section I'm interested in would be b minus a. That's the change in my x's. Okay, and essentially that right there, that's the slope. It's the slope, approximately, the slope of that little section of my function. Right? It would be like that, but it's approximately. Okay. All right, that's the equation you're going to use for the average rate of change of your function. Okay. All right, so let's do one of these. Let's say we're not looking at a graph, but we're given an equation and we're asked to find the average rate of change. Right? How would we do that? Okay, let's start with a function that is one that we can do pretty easily. Let's say it's x squared plus 7. And we're asked to find the average rate of change between the points x equals 2 and x equals 7. Okay. So to use this equation for the average rate of change, you have to know the value of the function at each of those 2 points. So that's the first thing you're going to do. Just go ahead and figure those things out first, right? So I'm going to find the value of the function at 2, and I'm going to find the value of the function at 7. Just calculate those things first, because you need to know those to use the equation. Okay, so the value of that function would be 2 squared plus 7, which would be 11. And 7 squared plus 7, which is 56. Okay, and then you're ready to go ahead and plug into your rate of change equation. And we'll just rewrite that here. All over b minus a. Okay, so your function at b, in this case, is the function at 7 minus the function at a, which is the function at 2. B is 7, a is 2. And then you just plug in what you just figured out. So the function at 7 was 56, and the function at 2 is 11. And then 7 minus 2 is 5. And here's just do the math now, math it out. 45 divided by 5. And that's 9. So the average rate of change for this function between 2 and 7 is 9. Obviously, it would be different if you had different x values, right? This function is quadratic. So if I pick 2 different x's, it's going to give me a totally different answer. But between 2 and 7, at least, the answer is 9. Okay. All right, let's do more. Let's do x minus 3 squared. Okay, same thing, find the average rate of change between the points x equals 1 and x equals 3. Okay, and again, the smartest way to do it is just figure out the value of that function at those 2 points first before you plug it into the equation. Okay. So the value of that function at 1, go ahead and figure that out. And the value of that function at 3, figure that out. Okay, so that'd be -2 squared. And 0 squared. And then you're ready to plug into your average rate of change equation. I always just like to rewrite it first. Okay, so your b in this case is 3. So your function at 3 minus your function at 1. All over 3 minus 1. So the value of your function at 3 is 0. And the value of your function at 1 was 4. Okay, so your answer is -2. Okay, now the next one I'm going to put up there, this will be our last one. I'm going to write the problem, and then I really want you to pause the video. Okay, take as much time as you need to work out the problem. Okay, and then once you get an answer, then you're going to come back and you're going to unpause the video, and you're going to see if we get the same answer. Okay, but I really want you to pause the video and try doing it on your own before you come back and see the answer that we get together. All right, so here's the problem is that you're going to do on your own independently with the video paused. Okay, so this time our function is going to be t squared minus the absolute value of 3t. Okay, what is the average rate of change between t equals -3 and t equals -1? Okay, so you're going to take a minute. You are going to pause the video and you're going to solve it on your own. And then you're going to come back and see if you get the same answer. So go ahead and pause it. Okay, so you're back with me. I guess that means you figured out the problem. Now let's see if we get the same thing. Okay, so first thing you have to do is you have to solve this function at each of those values of t, right? So first you're going to plug in a -3. That's going to give us a 9 minus the absolute value of -9. which is 9 minus positive 9, which is 0. So the value of that function at -3 should be 0. Okay. And then we plugged in a -1. Yes. So that'd be -1 squared minus 3 times -1. That'd be 1 minus the absolute value of -3, or 1 minus 3, which is -2. All right. So you got for your two values for the function, 0 and -2. Sometimes those absolute values, they can trip us up. Okay. Now we're ready to plug these in. Okay, so this is going to be the value of the function at -1 minus the value of the function at -3, all over -1 minus -3. So many negatives. All right, so this ended up being -2, and this ended up being 0. And minus a -3 is a +3. So -1 plus 3 is 2. So -2 divided by 2 is -1. Did you get a -1? Hope you got a -1. All right, that's it, guys. You're ready to do some problems on your own on the calculating the average rate of change. Thank you, everybody, for watching.